We experience time as a steady, universal rhythm, a ticking clock that moves at the same pace for every person on Earth. But if you could step outside of that rhythm, you could theoretically slow that ticking down, or see a moment frozen, completely fixed in place. Physicists treat time as a physical fabric. It is a material that stretches, compresses, and warps, depending on the physical forces acting upon it. Albert Einstein was the first to describe this relationship. He realized that an individual's experience of time is tied to their movement through space. The faster you move, the more that fabric bends. If time is a physical fabric that reacts to our movement, it raises a question that was once confined to fiction. Can we actually navigate through it? Science now approaches time as a frontier with its own set of rules. We are beginning to see that the possibility of travel depends entirely on which direction we want to go, and the physical limits of the universe itself. The first confirmed method for altering the passage of time is velocity. In order to actually see the effect, a physical object must travel at a significant fraction of the speed of light. This is the foundation of the twin paradox. Imagine two identical clocks. One remains stationary on Earth, while the other is placed on a high-speed rocket. When the rocket returns, less time has passed for the moving clock. If those clocks were people, the traveler would return to find that they have physically aged slower than the sibling who stayed behind. Beyond just speed, there is a second way to warp the clock: the presence of immense gravitational mass. This image of a black hole shows the most powerful gravitational environment in the known universe. Standing near an object this massive causes time to slow to a crawl relative to the rest of space. You would feel your own time passing normally, but across the galaxy, entire generations would live and die in the span of your afternoon. Massive cosmic objects act as a physical brake on the passage of time. Surviving near one is effectively a way to jump far into the future of the universe. This isn't just a theoretical concept for deep space. We see these same laws affecting the GPS satellites orbiting our planet right now. Because these satellites sit in lower gravity, their clocks drift out of sync with phones on the ground, creating a growing margin of error. To keep maps accurate, engineers program corrections into the software, forcing the time rates back into alignment. Traveling to the future is a verified, functioning part of our world. Modern navigation and the technology we use every day is built on the reality that time does not move at a constant rate. While we have proven we can move forward, the laws of physics are far less cooperative when we try to go backward. Does the universe allow for a journey into the past? One theoretical possibility involves wormholes. By folding the fabric of space-time, we could create a tunnel connecting two distant points, potentially allowing a traveler to arrive at their destination before they even departed. On paper, the math allows for these shortcuts, but in practice, attempting to jump into the past creates logical contradictions that science cannot yet resolve. This is known as the grandfather paradox. If you were to alter an event in the past that prevented your own birth, you would eliminate the person who was supposed to take the trip in the first place. Currently, we have no evidence that the universe allows for these breaks in causality. Our observations suggest that while the future is open, the past is governed by laws that prevent it from being rewritten. The past remains a mystery with no clear entry point. But as we continue to study the extreme edges of our universe, we are forced to keep refining our understanding of what is possible. For now, we remain travelers moving in one direction, waiting for the next discovery to redefine our limits.